Hi everybody. Alright, I'm going to just do sort of a quick warts and all design of a circuit board and layout, and just this is as much for me just to play with this recording stuff as anything else. So hopefully it's useful in the end. So what I'm doing, just the short version, is I've got an ESP826612E that I'm using as a temperature mote, and right now I've got a bunch of them that I have just perf boarded up. They're pretty flimsy, and the temperature sensor gets a little weird after a while. So what I want to do is I want to take the little chip that's on here, and I'm going to build my own board instead of hardwiring it to this carrier board. So just do my own design, and we'll try cutting it out. I'm going to aim to do it single-sided if it's possible, just to make it a little simpler. This is going to be a real simple design, so hopefully it won't take too long, and I can just do it all in one pass. So I'm going to call this temperature mote is what all of my little nodes I call motes, like there's some little dust motes, but that's just me. So start out creating a schematic here. Go ahead and save it. And basically just start adding parts. So there's my ESP12, and I also need a header, which will be a 2x4 for this case. I just need some pin headers, that's all I need. This will be for programming when I get to that point. And then I'm also going to need a couple of headers that are 1x3s for the temperature sensor. I'll go with those. So I'm going to put room on here for 3 temperature sensors. Mainly this is just some, I hope I get the number right, DS18B20, the one-wire temperature sensors. Nice and easy for me to hook these up to this, and basically I can hook as many as I want, and it enumerates them sort of from the closest to the furthest away, though not always, but usually. So a little bit of guessing sometimes to put the hand on there to raise the temperature and actually see which one's which, do a little bit of labeling, and then they'll stay in the same order usually. Can't say that I've ever had them change order on me. The last thing I want to add on here is a voltage regulator. Sometimes this will work. It's a 3.3 volt regulator package. Find the one I like. I believe that's it. So the last thing I need to add is just a connector that has a bit of extra space for me. Just a screw clamp is all that is. All right, a little info on some of these. This will be the power coming in. And then these will be the temperature sensors. This is the regulator or the programming. Now I'm just going to try to add a little bit of info here just so I know what's what on here. I'll rotate this around. There we go. And if anybody can tell me a better way of labeling these things, I would love to hear it. This is really what I'm testing. I'm trying to make sure that this programming header is going to work, and that's the biggest reason that I'm building this board out like this. Just to make absolutely sure that when I go to actually make one of these boards, this particular stuff is going to work on me. hate to have some boards made and turns out that it doesn't work. So now the reason I'm pulling these two GPIO lines out is because for the ESP8266, those are the two that are necessary to toggle to actually have the board go into programming mode. So now I know which is going where. So let me go ahead and hook these guys up. Transmit to transmit. Receive to receive. Now, I do that every time. Instead of wiring these things, which I understand is just really line drawing, should be using net instead, because net will actually give me the endpoints and it makes it a little easier for me. I have to admit, it does work a little better. Almost there. Where's the CHPD? There you are. Alright, so I'm going to save the VCC in the ground because I want to make sure that I get those nets properly hooked up. And I always have trouble if I don't do this first. I just want to add a little VCC so that I have that and a little ground. All right, now I can wire ground to ground and ground to ground and VCC to its various locations. Hopefully this works, because last time I did this I had some issues with it. So now I need VCC here and VCC here. Ground VCC. All right. Now I want to represent a ground here and a power in there. To the regulator. All right. So now there's those two pieces. All right, so the last thing I'm going to hook up here is going to be a resistor, because I need to pull up. So I'm going to just use a 10K, and I need just a small surface mount. think 603 is going to be too small though. Oh, this is one of the things that I simultaneously love and hate about this. It's trying to find exactly what you need in a mess of all of these. Those are all through holes. Oh, 0805s. We'll just go with the generic. So that's going to be a 10K. All right. Now, for my purposes, that's going to be a pull-up line. So it will be hooked to VCC, and it will be pulling up the center channel pin 2 on all of these. And that will also be connecting to GPIO4. Now, the other two pieces, I should finish this out by actually connecting the pull-up. Now, that has my pull-up. This is pin 2, and this is connected to GPIO4. The other two are going to be connected to VCC and ground. So pin 3 gets ground, and I'm going to copy a ground in here just to make it a little easier on myself. All right, so let's do a quick check here. Our programming headers are hooked up. VCC comes in there, VCC there. Out from the regulator, also VCC. VCC for the chip itself and the pull-up resistor, and to the pieces that are going to be the power side of the bus. Ground, which this is really ugly, but ground is to there, or to our voltage regulator, the chip itself. Missed it right there. All right, ground to ground. GPIO 2, GPIO 0. Transmit and receive are hooked up. Reset is hooked up. Chip enable is hooked up. All right, well, I think that's everybody. Let's save that before it gets lost. So now we're going to add a new schematic to this. So easiest way is just to switch to it. Sorry, we're going to switch to the board itself. Brain will kick in any time now. There it is. All right. So now we have all of our parts and our empty board we're going to work from. So just to get things in here, we'll figure out what we're going to do. This particular board, I'm going to hang the ESP over the edge because I'm going to be cutting this on my CNC machine, so the clad will interfere with the antenna. And we'll put the regulator somewhere. Put it there for now. Programming header. I personally, the way I try to do this is to look for the fewest crossovers as I can find as I'm adding things in, just to try to minimize having to clean that up. Alright, well, I'm going to reverse this guy a little bit. There we go. That makes life a little easier. Alright, so we'll put our temperature jumpers in right along here. And throw the pull-up in. Well, that's going to be interesting. And jumper 5 seems to be a leftover. Did I drop one? Yes, I did. Alright. I'm going to try tightening this up just a shade more. Alright, let's see if we can clean that up a little. Alright, now we can wrap this thing. Now for my purposes, since I'm going to be putting this on my CNC, I'm going to use some big fat traces on it. You'd probably never actually use anything this big to do actual manufacturing with, but all right. Now keeping this thing single-sided is going to be a real pain in the patootie. I mean, it's not really critical. I can air wire it from the back. I just really won't be cutting the back side of it. And it looks like the ground is definitely going to have to get jumpered. So let's see. Of course, it's way down here. Well, let's try this and see. Yeah, I don't think so, Timmy. I'll move this back to this side. That takes care of the pull-ups. So now, even though that's on the bottom, I'm treating it as if it were a via, but when I actually go to assemble this, I'm probably only going to actually cut the top part of the board. So the bottom piece down here will just be a hole. I'll do a drill for that. I probably should make these guys a little bit larger though. that should do for that for now. I should be able to put that in place and then drill that out and have enough copper left to actually be able to solder in that jumper wire there. There's probably a way of routing it through the air route, something like that. So the whole point of me doing this was that I've got this little programmer. It's made for ESP01s, right? It's got this pin header on it. And I was trying to make it so that I could take the board and have this pin header as is and just be able to drop that programmer right onto it. And that way I wouldn't have to use jumper wires or make a custom cable. But this layout gets really ugly otherwise. So I have to decide if I want to have a whole bunch of little pieces that go off of this and some jumpers, or try an entirely different layout, or try to do a two-sided layout. Artificially constraining myself to that, pretty bad idea, actually. Without going with the two-sided design. I could have simplified it a lot. These, I'm pointing at the screen, all of these little air jumpers that I'm having to put in with these non-existent back pieces. So many jumpers. Hard to make something that I can route on CNC and still be able to have enough clearance to actually get all the parts on there though. Alright, well, it passed the DRC, at least for the base set of rules that I've got on it. Okay, so it took me just a little bit of checking so I could actually make sure I had this stuff in the right place. Notice the documentation. So basically on what location to put it in, how to get there. So basically for me, I create a directory underneath my projects folder where I have my scripts that I use. In this case, PCB-GCode. I went to the website where it's currently living at. In this case, that URL right there. And the PCB-GCode zip file is there. Unzips into the folder. There's a nice set of documentation that talks about how to use it, and if there's a PDF file in there, that's what I was looking at. And the other piece of it. So now we can go here. We can run a ULP, and then I want it to come from my folder. Let's just check the setup and see if there's anything I'm missing. In my case, I'm using a Mach 3 CNC machine. Mach 3 controlled CNC machine. So if there's anything in here that's insane. I don't want bottom outlines, and I don't need bottom drills. I just need the top outlines and the top drills. Those numbers look sane for mine. I believe that I set this up the last time. I don't see anything crazy, so now I will. All right, so what it does is it does a fill. I'll pull this viewer out of the way. It does a fill, and it repetitively carves away the fill to do isolation traces. So what you end up with in the end will be the board outline, and it's going to do roughly 5 passes. Each pass will be just a little out from the previous one, and that should isolate the copper, assuming that my CNC machine is level. Usually what I do for that is have a plate that I carve with an end mill before I actually put this in it, and then actually carve it. So that way I'm pretty sure even if things have migrated around, I'm still fairly flat on the CNC machine. So, seeing that, I'm going to close the viewer, tell it OK. Now, in theory, I'm going to come out here to my projects. I should have some, there we are, a drill and tap. So these are the 2 files right here will give me what I need to run in the CNC machine to actually do the top drilling and to do the actual cutting for it. So these are the drills that it says that I cut the holes for. I'll find something that's probably in between in my collection, probably a 1mm, just for simplicity, and I'll cut them all with the 1mm. Then I may have to manually add a little bit extra to some of the larger pin holes on the connectors to actually drill those the rest of the way out. But it just gets to be a real pain in the ass to have to do multiple drill changes when I'm just doing this test board. So in this case, the G-code for this one is going to have a tool. Oh, come on, where's the tool? Doesn't indicate it in here. But basically, I'm just going to have a V-carve bit. I'll go back and verify this, but usually my settings were for 60 degree, which is the angle of the point. It's wide enough that it cuts decently, but not so wide that it loses accuracy, and not so narrow that it doesn't actually clean up all the copper. I'll finish editing this video, and then I will make, as soon as I can get into the garage, if it warms up enough this weekend, I will go out and actually cut this board and then test it out and see if it actually works electrically. So if you've managed to stay through all of this and watch this, thank you very much, and we'll see you for part 2.